Hello, I'm Betsy Jameson, and I'm going to take you through the basic steps on how to draw a Lewis structure. If you'd like to read about this in your textbook as well, you can look in Chang in section 9.6. So Lewis structures are very helpful. It's nice to be able to go from a chemical formula to think about what the molecule actually looks like. And Lewis structure, these are the basic steps you would follow in going from a chemical formula. In my example is going to be this NF3 molecule here. So, what does NF3 look like? Which atoms are bonded together? That's what we're going to be doing in how to draw a Lewis structure. So step one, we have to write the skeletal structure of the molecule, which is basically figuring out which atoms go next to each other. So in general, you want to place atoms that are going to be bonded to each other next to each other in your skeletal structure. And a general rule of thumb is to put your least electronegative atom in the middle. So again, least electronegative atom goes in the middle. And another tip is that hydrogens, H, and fluorines, F, are usually on the ends of the molecule. They usually are not the middle. Hydrogen, because it only likes to have a single bond, right? In terms of the octet rule, it only likes to have 2 electrons around it. And fluorine, being the most electronegative atom, doesn't really like to be in the center of a Lewis structure where it might have to share electrons. So in general, when you're making your skeletal structure and thinking about, how to take a chemical formula like NF3 and draw which atoms are going to be next to each other, least electronegative goes in the middle, and hydrogen and fluorine are usually on the ends. So let's go ahead and do step one with our molecule here. Our example is NF3. When I think about it and I think about electronegativity, right, I think about nitrogen, its electronegativity. If I look on the scale, electronegativity is a value of 3.0. I just mentioned fluorine is the most electronegative atom, and it also usually goes on the end, but right, its electronegativity value is 4.0. So thinking about who's the least, it's nitrogen when comparing those two. So even though nitrogen is very electronegative compared to some atoms, in this case, when I'm just comparing the nitrogen and the fluorine, nitrogen would be my least electronegative atom. And so I'm going to put the nitrogen in the middle. So nitrogen's going to be in the middle. And then I'm going to surround it with fluorines. And there are 3 of them from the chemical structure. I'm going to go ahead and put a little line in here so you can kind of separate off the structure. And again, I'm not really making any inferences about the shape here. That's something we'll address later in Chem 111, but I want to put nitrogen in as the central atom and the 3 fluorines around it because they will end up bonded to the nitrogen. So that's the end of step 1. Okay, so moving on to step 2, I've gone ahead and just copied over here on this slide my skeletal structure from step 1. Step 2 involves counting the total number of valence electrons. So I'm going to be making bonds in this molecule, and I need to know how many electrons that I can use to make these bonds. And so by counting the total number of valence electrons that each of these atoms brings, I'll be able to do that. NF3 is a neutral molecule, so these 2 things don't apply for our example, but they will for some examples we'll look at later on. If you count the valence electrons for each atom. If your species is a polyatomic anion, you would add in electrons for each negative charge, and if you have a polyatomic cation, you subtract electrons for each positive charge on the species. So I'll look at these later. They'll come up in some of the examples we'll look at later. Since it's a neutral molecule, all I have to worry about in our NF3 example is counting the total number of valence electrons. So I'm going to go ahead and do that. So for each nitrogen, right, nitrogen, and when I think about nitrogen, it has 5 valence electrons. And fluorine, each fluorine has 7 valence electrons, and I have to multiply by 3 because there are 3 fluorines. So that would be a total of 21 electrons. And if I add these up, the 5 and the 21, I get a total of 26 electrons that I can use to make my Lewis structure. So I need to know this because I'm going to start drawing bonds, I'm going to start putting in lone pairs, and I have to know that I only have 26 electrons to work with, and I'm going to have to keep that in mind. Okay, moving on to steps 3 and steps 4. Now that I have a skeletal structure for my molecule and I know how many electrons I have to work with from steps 1 and 2, now I have to start making bonds. So that's step 3. So step 3 says draw a single covalent bond between the central atoms and the surrounding atoms. So let's go ahead and do that. So in order to do that, I'm going to put a bond here between nitrogen and fluorine, a bond here, and a bond here. Now, in doing so, right, this bond is indicative of 2 electrons. So I've used 2 electrons here, another 2 for 4, and another 2 for 6. So I've used, of my 26 electrons, I've used up 6 of them in making the single bonds. Okay, so that's step 3. And then step 4, now what I need to do is complete the octet of my outer atoms. And in order to do that, I'm going to put electrons on as lone pairs. An important note, I have to keep track because I know, right, in step 2, I counted that I had 26 electrons total. I can't go over 26. I've already used 6. So let's go ahead and put in some lone pairs. So I'm going to start. I have already put in 2, 4, 6. And now I'm going to start putting in and completing the octets of the outer atoms. So 6. So this will be 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so I've now put in the electrons on the outer atoms, each one of them. So this fluorine has 2, 4, 6, 8. 2, 4, 6, 8, 2, 4, 6, 8. So my outer atoms are complete, and I've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 of my 26 electrons to do that. Okay, so now we're moving on to step 5. Okay, so this is one of our last steps. If after doing steps 1 through 4, which we have done, the central atom does not have an octet, you will need to complete its octet. Okay, so this is going to be the case for us because if I look at this nitrogen, it has 2, 4, 6 electrons around it, so it does not have a complete octet, so we are going to need to complete it. There are a couple ways you can do that. So if you have extra electrons, you can use those. This is going to be the case for us. We had, if you remember, 26 electrons when we counted up how many valence electrons we had total. So we had 26, and at this point we've used 2, 4, 6, 8. 10, 12, 14, 16, 18, 20, 22, 24. So I've used 24 of my 26. I actually do have 2 electrons left, and I can use those to complete nitrogen's octet. So I'm going to go ahead and do that. And go ahead and do that here. So that's nitrogen. So now, if I look at nitrogen, it's got 2, 4, 6, 8. It has a complete octet, and I've used all 26 of my electrons. So at this point, I'm going to say a little check. I've actually completed this Lewis structure. Now, I'm going to say a little statement here. If you actually don't have extra electrons, and this is going to happen with some of the examples we have. So if you have extra electrons, great, you can use them. But if you don't, then this is where you have to try making double and triple bonds to the surrounding atoms. So getting the outer atoms to share their electrons with the atom in the center. So to do this, you transfer lone pairs from the outer atoms to make these double and triple bonds to the center. And I'll have some examples on the next slide where we can go ahead and do that. Okay, so now I'd like to do a few more examples just to give you a little bit more of a sense for how these rules work in drawing Lewis structures. So I would say for these examples, if you feel like you want to give it a try, you're always welcome to stop the video, draw the Lewis structure yourself, and then turn the video back on to see how I solve the problems. So I'm going to start with carbon dioxide, CO2. So if you'd like to try that on your own first, go ahead and stop the video, give it a try, and then turn it back on. Okay, so for carbon dioxide, I've got carbon and I have oxygen. And if I compare the electronegativities of those two, carbon is the least electronegative of those two atoms. So that means it's going to be in the center. So step 1, drawing my skeletal structure, I'll put the carbon in the middle and the oxygens on the outside because they're more electronegative. I need to add up the number of valence electrons. That's step 2. So carbon has 4 electrons. Oxygen has 6 valence electrons, right, times 2, so that equals 12 electrons. It's a neutral molecule, and so that tells me that I'm working with a total of 16 valence electrons. Okay, now I'm moving on to step 3. I have to draw a single bond between the central atom and the outer atoms. So I will go ahead and do that. So 2, 4, it takes 4 electrons to do that. The next step, complete the octets of the outer atoms. So I've used 2, 4. This will be 6, 8, 10, 12, 14, 16. So I've actually used all 16, and right, I can go ahead and point to that. So I've actually used all 16 of the valence electrons that I have to draw this Lewis structure. And now the next thing I have to do is look at the central atom and see if that has a completed octet, right? So right now oxygen is complete, this oxygen is complete, but if I look at this carbon, it's actually not a complete octet. It only has 2, 4 electrons around it. So in this case, what I need to do is I'm going to need to, I don't have any more electrons, so I can't just add some to the carbon. So what I need to do is have the oxygens that are on the outside share their lone pairs. And so since carbon has 4, I need to get 2 more pairs of electrons in there for carbon to have a complete octet. So what I'm going to do is I'm going to share this pair from this oxygen, this pair from that oxygen, and then I'm going to go ahead and redraw the structure with those. Those are now going to be double bonds. So carbon double bonded to an oxygen, double bonded to an oxygen, and now each oxygen has 2 lone pairs around it. Okay, and I'm going to draw a little box around this Lewis structure, and let's just double check it. So now this carbon has 2, 4, 6, 8. It has a complete octet. This oxygen has 2, 4, 6, 8, and this oxygen has 2, 4, 6, 8. So all the atoms have a complete octet, and I used 2, 4, 6, 8, 10, 12, 14, 16. I used my 16 valence electrons. So I will go ahead and give this a little check. That's the Lewis structure for carbon dioxide. Okay, the next example I want to do is Cn-, the cyanide anion. So cyanide has carbon and nitrogen. Because there are only 2 atoms, they're going to be bonded to each other. There really isn't a central atom in this case. So this is my skeletal structure, just carbon and nitrogen next to each other. I have to count electrons. So carbon has 4 valence electrons. Nitrogen has 5 valence electrons. And then I have the negative charge. So for each negative charge, you add 1 electron. That was there in Rule 2. So we're going to add 1 electron for that. And so I get a total of 10 electrons that I can use in this Lewis structure. So I'm going to go ahead and start. So first thing I want to do is put a bond between the carbon and the nitrogen. So I'm going to go ahead and do that. That's 2 electrons. And then I'm going to start completing the octets of each atom. So 2 in the bond, 4, 6, 8, 10. And now I have to stop because I've actually used up, right? I only had 10 valence electrons, 2, 4, 6, 8, 10. I have to stop there. Problem is, of course, this carbon only has 2, 4 electrons around it. It doesn't have a complete octet. Nitrogen's happy, 2, 4, 6, 8. Carbon is not 2, 4. So I have to get nitrogen to share 2 more of its lone pair. So I'm going to ask nitrogen to share this lone pair and this lone pair. And then I'm going to go ahead and redraw that structure. So it'll be a carbon with now a triple bond to the nitrogen. Nitrogen will keep 1 lone pair. Carbon will keep lone pair. And then I can say 2, 4, 6, 8, 10. So I'm consistent with my 10 electrons. Carbon has 2, 4, 6, 8, a complete octet. 2, 4, 6, 8, a complete octet for the nitrogen. And the other thing that I like to do is I like to draw a little bracket and put a little minus sign here, and I'll just go ahead and draw a little box around that. So that's my completed Lewis structure. So I like to put the little bracket with a minus sign because this is Cn-. It's a negatively charged polyanion, so I like to put that bracket with a minus charge there to indicate that. So that's cyanide's Lewis structure. Now the last example I want to do is H3O+. So again, if you want to give it a try on your own, why don't you go ahead and stop the video, and then you can check your answers against mine after. Okay, so H3O plus, it has hydrogen and it has oxygen. And you might remember from earlier on the slides, hydrogen is usually not in the center. So oxygen here, even though it's a very electronegative atom, is going to have to be the central atom because hydrogen usually is only on the outside. It's one of the surroundings. So my skeletal structure here is going to look like an oxygen with 3 hydrogens around it. And again, I'm not trying to apply any shape. I'm just putting them around there. Okay, so that is my skeletal structure for the molecule. Now I have to count valence electrons. So I have oxygen that has 6 valence electrons. I have hydrogen, each one has 1 electron, and there are 3 of them, so that gives me another 3 electrons. And then it has a positive charge, so I have to subtract 1 electron from the total because it's a positively charged, it's a polycation, polyatomic cation. So if I do that, 6 plus 3 is 9, minus 1, that gives me a total of 8 electrons to work with. Okay, so now I have my skeletal structure here. I know how many electrons I have to work with. The next step is to draw a bond between the central atom, in this case oxygen, to those outer hydrogens. So if I do that, 2, 4, 6. Okay, the next thing to check, right, the octets of the outer atoms. Hydrogen only wants 2 electrons around it. So this hydrogen has 2, this hydrogen has 2, this hydrogen has 2. So in this case, even though it's not 8 electrons, these hydrogens have what we would consider a complete octet. And then I have to go back and I have to say, okay, what about the central atom? So when I'm looking at my central atom, I say, okay, oxygen has 2, 4, 6. So I've used 6, but you know what? I actually had 8 electrons. So in this case, to complete oxygen's octet, I can go ahead and add a pair of electrons here. Now I've got 2, 4, 6, 8. Oxygen has a complete octet. The hydrogens are happy. And so this is actually a complete Lewis structure. I've used 8 out of my 8 electrons. And I'm going to go ahead, and the only last thing I'm going to add is a little bracket with a little plus charge over here. I'm going to go ahead and circle it and put a little check mark. And that's my Lewis structure for H3O+. And again, there's lots more practice you'll be doing with that. We're going to be building on these skills, talking about things, maybe you've heard of them before, like resonance. So these are really just the basics meant to get you started, and we're going to see ways to kind of like alter Lewis structures to get a better idea and be more indicative about what the bonding is like in molecules.